So, what's up mga ka-che? It's Kuya Dale here and I'm back with the next part of the series, which is chemical reaction engineering. So, we're finally done with chemical engineering thermodynamics. So, we're now moving on to the next part of the next subtopic of the day 2 ng subject sa chemical engineering board exam. So, let's not delay any further. Okay, so let's begin with the lecture. Okay, so now we will begin with a new topic, the chemical reaction engineering. Okay, so I will answer I will answer more problems, right, today. So, and this the problems from these slides are coming from the reviewer for chemical engineering chemical engineering licensure examination, this book. Okay, so this is what I've been using, been teaching you in my previous videos. So if you want to buy this book, so you can buy this at National Bookstore or sa online shops sa Shopee or sa Lazada. And this is not sponsored by MRII. This is published by MRII. And if you want to review with me, please buy that book so that you can understand what I'm saying and you know where I'm coming from. Okay, so next, let's dive right in. Okay, so number one, so it says here the unit of K for a first order elementary reaction is 1 over time, concentration over time, 1 over concentration, or 1 over concentration times time. So let's solve this using differential equations. So although we can know, or we we can by just picking out from the letters, but for me, as much as I can, I want to solve it using math. Okay, so uh, for a first order reaction, okay, first order reaction, so meaning there's an A there. So this is the differential reaction for first order reaction, dA over dt. So A corresponds to the amount of the substance there, is equal to K, a proportional constant, and then A. So let's integrate. So K dt. Okay, so let's integrate from AO to A, then 0 to T. Okay, so we have ln A over AO. So that's the answer, and then KT. And then you will see, so transpose T to the other side. So ln AO over T. So you can see now that K is equal to 1 over time. Diba? 1 over time. So that's letter A. Okay? So that's how easy it is. So number 2 is actually connected to the previous number 1. So which of the following cases does the reaction go farthest to completion? So as you can see, the reaction goes to completion if it has a big K, okay, big specific rate of reaction. Okay, so what is the biggest? So what is the largest number of the specific rate of reaction here? Is that it's letter A. Okay, so it can be if this, diba? This increases, so this also increases. Okay, so that's how it will be explained. And lastly, the number 3 in this slide, so the number of CSTRs in series may be evaluated graphically by plotting the reaction rate RA with concentration CA. So the slope of the operating line used which will give the concentration entering the next reactor is we are given the choices. So how do we analytically solve this, okay, so we must have the we must know the how the equation for the CSTR is derived. Okay, so CSTR is basically, it's just this. Okay, so you have a reactor there, you have a stirrer. So CSTR because stands for continuously stirred tank reactor. So that's CSTR. Okay, so we have a rate in. So let's name that FAO. So molar flow rate in and molar flow rate out. So FA. Okay, so the general equation for this is the accumulation is equal to in minus out plus generation. Okay, this is found in Paris equation 7-44 sa Paris. Okay, so we have what do these comprise, diba? So we have the accumulation term, so DNA. Let's name our species A. So A, and then DT, and then we have the molar flow rate in FAO, and then FA, then plus the generation nga term. So it's RA/dV. Okay, so let's integrate that to V. But in a CSTR, so CSTR, we have assumptions there. So one assumption is that it is at steady state, and then it is well mixed. Okay, so what do these assumptions mean? Okay, so if we say steady state, so meaning the accumulation term is 0, and then if we say that it is well mixed, so meaning the composition, for example, in the CSTR, so the composition right here is the same as right here, right here, right here, right here, right here. So it is uniform all throughout. So meaning there will be no variations in the volume here. So we can simplify this as 0 is equal to FAO minus FA. We will make the volume term constant instead of if it being in differential form. Diba? So we can also let's transpose that so that we can have the because we are going for this, diba? So it is reaction rate RA with concentration CA. So meaning RA is here and then CA is here. So we have to have the Y at the RA at the y-axis and then CA at the x-axis. So meaning RA is the dependent variable and CA is the independent variable. So we have to somehow transform this to form that we are familiar with. So FAO minus FA RA. So that's that. Okay? But we know that molar flow rate, so molar flow rate is actually equal to the concentration times the volumetric flow rate. So volumetric flow rate, so let's just name that like curving V. Okay, CaCV. So CaCV. Next is that we can transform this to back to we have to we can actually insert this here. Okay, so we can actually insert that here. So inserting this here, and also we have okay, so we can also express the F in terms of conversion. Okay, so the molar flow rate, we can also express that in terms of conversion. Okay, so it is FAO. So So phi minus shuffle. Okay, so that's how we can transfer. We can express that in terms of conversion, and uh, we can replace them here in the equation. Okay, so we have let's write here. So V is equal to let's substitute minus plus okay over ra. Okay, so this is 0, diba? 0, and then after that we this is the only thing that's remaining sa ra, ba? Ra, and then let's uh, substitute fauvo to here. Okay, so we have fauvo sa over RA, negative RA. And then, actually, uh, we know that V, diba? The volume over VO, the volumetric flow rate, is just the resident time. So, residential na siya. Time residential. And then, you have cow sa over negative RA. And then we will now have this our goal. So let's transpose this. So let's rearrange there. Let's rearrange. So RA is equal to okay. So that's the equation that we are looking for. And then as you can see, CAO is the CAO here. CAO is the independent na variable, and then the dependent variable is the RA, diba? And then as you can see, our slope is tau. Okay, so tau. So if we go back, this is our slope. Okay, so it's really long na explanation, but it helps that you will know that that derivation of the equation. Okay, next, so let's move to the next number. So the reactivation energy EA of of a reaction may be lowered by increasing the temperature, decreasing the temperature, adding a catalyst, or removing the products of the reaction. Okay, so how do we lower the activation energy? So one way is let's solve it, diba? So you can solve it actually. So how do we solve for it? Okay, so look for the Arrhenius equation. It's in your Paris. Okay, so it's written as like this in your Paris. So it's in chapter 7 actually. EXP EA RT. Okay, so RT, and then after that um, let's isolate these variables, and then let's solve for EA in terms of T. Okay, so how do we do that? So let's take the logarithm of both sides. Okay, so lnk, and then lnk also here. Ko is actually the pre-exponential factor. So next is the if you take the natural logarithm of this, because it's in exp, So it ART, ba? Ano na siya? The next is you have to, let's put EA in another side and then T on the other side. Okay, so we can achieve that by KO, and then we have let's diba? EA RT, and then you can have it transposed to the other side, diba? So EA, so negative RT ln K of KO. Okay, so as you can see, if you EA and T are directly proportional. So okay, so you have to, if you decrease EA, you have to decrease the temperature. So you have to decrease the temperature. Next is the mechanism of a reaction can sometimes be deduced from the temperature of the dependency of the rate, so the net reaction, rate equation, or the activation energy. Actually, this is no-brainer na. So if you read the law of mass action, yeah, let read it on page 7-6 in your 8th ed na na Paris. So the answer there is the rate reaction. Why? So okay. So tangka lang ingani ang kuan ang reaction. So yan. So CACB. So the mechanism of a reaction, meaning that pertains to zeroth order, the first order, second order, or third order. Okay, so we can know from the rate equation what is the mechanism of the reaction through, if it is second order, or what, through what, knowing what order it is. Okay, so if we know what the numbers of here are, so here is 1, for example, here it's 1, about 1 and 3, so we know that it's in third order reaction, so meaning we can know also the mechanism of that reaction through the rate equation. Okay, so that's number 5. And then for number 6, it's also in the same page in your Paris, letter D, law of mass action. Okay, so let's go to number 7. So the equilibrium constant in a reversible chemical reaction at a given temperature. So if it tells us what it is dependent on, diba? What where does it depend? Okay, so the equilibrium constant, so meaning the letter katong K, specific rate of the reaction, tong K, in reversible chemical reaction at a given temperature. Okay, so temperature. So as you can see, it tells us where does it depend on, but as you can see, in our K, it only depends on T, di ba? And also the EA, the activation energy. That's all the K depends. So it does not depend on initial concentration. It does not depend on the concentration of the products, and it's not a characteristic of the reaction. Meaning, this does not depend on the initial concentrations. This is the only answer there. Number 8, so which of the following statements best the explanation of the effect of increased temperature and the rate of reaction? Okay, so as you can see in the choices, so it increases the number of particles with the necessary activation energy, enables the reacting particles with the necessary activation energy, lowers the activation energy for the reaction, or it enables the activated complex to be more easily converted to the products. So actually, the answer here is it increases the number of particles na with the necessary activation energy. So how is this explained? Okay, so for example, you have here a beaker na you have particles, the molecules here. Imagine that, and then you have to react that with something ngani. Okay, so you have to react with something ngana. So the number of particles with the necessary activation energy, because the reaction cannot go to completion without overcoming that barrier, which is your activation energy, diba? So for the reaction to happen, you have to overcome this EA. So this is the activation energy, so you have to overcome that. So in order to overcome that, so you have to increase the number of particles with the necessary activation energy by increasing its temperature. Okay, so this not the number of particles stays the same, but the number of the particles with the necessary activation energy must be increased. Okay, so because there are only a number of particles not enough to sustain the reaction. Okay, so that's what it means. Next is the number 9. So if the rate of the reaction is independent of the concentration of the reactants, the reaction is said to be. So if it does not depend on the concentration of the reactants, meaning dili siya first order, second order, third order, meaning it is zero order. Okay? Next is the specific rate of reaction is primarily dependent on, so I have said it earlier, it's dependent on temperature. Next, the rate of the reaction is influenced by, so is not influenced by. So the rate of reaction is not influenced by. So the rate, so CaCb utang talang kana magyapon. So meaning it depends on the concentration of the reactants, diba? So it depends. Concentration ba CaCb concentration. So it depends. Nature of the reactants, yes, it depends. Temperature, it affects K, diba? If it affects K. So meaning the only factor that does not contribute here is the molecularity of the reaction. And it's also the answer actually in the answer key. And also number 12, so for the reaction, kining reaction with, we are given the reaction rate equation. So the reaction is said to be, so as you can see, if you notice the exponents, diba? So if you say that it is an elementary reaction, so meaning the exponents here must be the same as the stoichiometric ratio here, stoichiometric coefficients, stoichiometric coefficients here. But as you can see, Ca, its exponent is 1, but here in the reaction, its stoichiometric coefficient is 2. So it is not the same. And also in B, the exponent is 2, but in the stoichiometric coefficient is 3. So meaning that this is non-elementary. Okay? Okay, so let's move on to number 13. So chemical reaction rates in solution do not depend to any extent upon. Okay, so as you can see, chemical reaction rates. So we have established that it really depends on temperature. So check, it depends on temperature. Concentration, yes, it depends on concentration. And then catalyst actually really greatly affects the rate, because it affects the how fast it is going or how slow it is going. So it is checked. So the only thing that reaction rate does not depend on is pressure. Okay, so pressure. So because solution, diba? Solution man eh. Solution. So meaning it is dissolved in a liquid solvent. So liquid solvents liquids are not susceptible to any changes in pressure. So thus the pressure does not affect the reaction rate. Okay? So let's move on to number 14. So the overall order of the reaction for the elementary reaction A plus 2B yield C is, assuming this is elementary, diba? So this is 1. So R. So tangta lang RA. So K, diba? So CaCb². So 1 plus 2 plus 3, diba? 1 plus 2. So the overall reaction is third order. Next, if the volume of a container for the above reaction, so this problem here suddenly reduced to 1/2 of its original volume with the moles of A, B, and C maintained constant, the rate will increase by a factor of what? Okay, so let's write that here. So kCaCb², diba? So as you can see, diba, Ca, what unsa the equivalent na niya? So Ca is equal to Na over V. Okay, so diba concentration man is, meaning moles over volume. And then we are told that the V is reduced to 1/2. So nahimo na siyang 1/2 karon. 1/2. And also Cb, di ba? Pala, Ca and also Cb and B. 1/2 V. Kasi same naman sila container, di ba? So same lang ang volume. So 1/2 then 1/2. So let's substitute that here. So K. So we have as Na over 1/2 V. And then we have, actually we can write this at the top para sa yun. So we have 2 NB over V. We have 2. So 2 times 2 squared is equal to 8. Diba? 8. Then K. Na NB squared over V cubed. Okay? So as you can see, the factor is 8. Diba? So letter B answer. So the rate of letter number 16, the rate of reaction of B in terms of Ra, where here we have same yapon siya reaction is, so this is actually easy. So di ba in the previous, so in number 14, so we have that. So Ra, this is Ra, di ba? Ra, the rate of disappearance of A is equal to the 1/2 kay kining 2 is imo siya i-reciprocal para may mo siya sa rate niya bitaw. So RB and RC. So rate of appearance of C. So dili na siya, so this is negative de kay rate of disappearance ma. Rate of disappearance of B is equal to rate of the 1/2 the rate of disappearance of B is equal to the rate of this appearance of C. Okay, so let's just find the proper interpretation here. So rate of reaction of B, so RB in terms of A, di ba, RA. So let's just transpose that there. So 2RA, di ba? So pareho na sila negative, so positive rin hapon. Answer is letter C. Diba? So next, net rate of reaction of an intermediate is 0 gina siya. Intermediate man. So gabutang talang ana. C. Okay. So you know that this B will be produced by A, di ba? by transforming A to B, but it will eventually be consumed to produce C. So meaning wala na siya kuan, net rate of reaction niya is 0, okay, because it is formed as it is consumed. So the net rate is 0. Okay, yan. Number 18, for the reaction for A plus B plus 2C plus 2D, which of the following statements is not correct? Okay, for me, I really had the hard time answering this, but since I found the easiest way for this, okay, so clue is the appearance and disappearance. Okay, so rate of disappearance of B. So is B disappearing here, diba? So yes, B is disappearing here. Appearance of C, so C is appearing, yes. Disappearance of C, is C disappearing here? No, diba? So meaning siya na ang not correct. Next, so the collision theory of chemical reactions maintains that, okay, so 19, rate is directly proportional to the number of collisions per second. That is the kinetic molecular theory. Read it in the Paris. That's in the Paris. And also, the reaction is known to be first order in A. So straight line will be obtained by plotting. So if you can remember the first problem that we solved, diba? So it's ln A over A O then KT, diba? So we can actually transform this to CA, diba? ln CA and separate the CaO. Yan. Then KT. So that's that. And then you can see that we have to plot ln CA versus time. Okay. So one way that we can memorize this, I will write here a table of summary. So this is what you have to plot in your calculator. So and we have MB. Okay, so XY this is what you have to put in your calculator. So these are the X and Y values, and the M or B here is from the Y equals MX plus B na Y equals MX plus B na format. Okay, so M is equal is the slope and the B is the y-intercept, diba? So order, so we have 0, 1, 2, 3 here. What you have to put in the X value is the T. All X, butangin mo T. And then for Y, so these are now different because in the zero order you have A. For the first order you have ln A. For second order you have 1 over A. And then for third order you have 1 over A squared. Okay, so what is the slope there? So slope negative K, tanan slope. So what about the y-intercept? So you have AO, ln AO, 1 over AO, and then 1 over AO squared. So that's what Sir Lowen wants us to memorize. Okay, so you have to memorize that. Okay, so we have to, for a first order, so first order in A, so first order here, so meaning we have to plot log A versus time. Okay, that's how do we use this table. Next, Second order. So second order, which of the following paths will give a straight line? So meaning we have to look back here. So second order, di ba? We have 1 over A and time. Okay? So we have 1 over A and time. 1 over CA and time. So that's letter B. Okay? So for number 22, the activation energy of a reaction can be obtained from the slope of a plot of. Okay? So let's look at the the Arrhenius equation once again. So we have K, KO, EXP, EA over RT. Diba? So yan, we have that. So if we linearize that, we have lnk and lnko minus EA over RT. So we can know now the plot of, diba? So we have log K, diba? So lnk or the logarithm of K, and then we have this here also. So this is the y-intercept, and this is the, we have to find the slope, diba? So slope here is 1 over t, diba? And then ang iyahang y nga value is lnk, diba? So yung x nga value, and then this is the slope, EA over r, diba? EA over r is the slope, negative EA over r, then x nga value is 1 over t, y is ln k. So 22 is letter A. Okay, so next, for the reaction of A plus B equal to C, when C is doubled, so the rate doubles. So when CB is doubled, the rate increases fourfold. So the rate law is, so we have to find the description here, di ba? So ingon siya diri that when CA is doubled, so CA is doubled, so mo-double po ang rate, di ba? So if i-double po na to ang CB, na fourfold siya, so naay mo siyang 4, di ba? So that means this is squared. You can see the pattern now. So meaning the rate law is the rate equation is CB's yan RA, di ba? So ini, so we found that easily. So next is the pressure cooker reduces cooking time because what really does your pressure cooker do? Diba? So does it evenly distribute the heat? Maybe, but that's not the reason. High pressure tenderizes the food? Actually, no. Actually not. The large flame must be used? No. You can actually use it in your stove, but the temperature is very high. The answer is the boiling point is elevated because in that pressure cooker, so di ba pressure cooker, then naato siya katubit ang murag whistle diri na magtuyok-tuyok dayon because it releases the pressure. That's the sound that your pressure cooker makes when you want to tenderize the meat nga gahi kayo. So, gusto niyo pahimumok ang karne nga gahi. So because boiling point is elevated, because of its high pressure, the temperature also increases. So if instead of water boiling at some temperature na 100 degrees Celsius, so it boils at a higher temperature. So that results to mahumok na rin ang karne because of the really high na temperature. Okay, so that's how it is explained. Please ask me for more explanation kung dili nyo nasabtan. Okay, so next, catalyst can so shift the equilibrium of the reaction? No. Diminish the activation energy? Maybe. Increase the rate constant of a forward reaction? No. Decrease the pressure? No. So according to the answer sa reviewer, it diminishes the reactivation energy. Okay, so which it really does. Why? As you can see here, let's uh, let's this is the activation energy of the uncatalyzed reaction. Okay, let's assume that it is that. So, but if we put use a catalyst, so the activation energy actually lowers. Okay, so but it here is one misconception that our teacher corrected, because it really does not lower the activation energy, but it provides an alternate pathway. Instead of just colliding there randomly, it the the catalyst provides a surface, di ba? Provides a surface that where the reactants can stick and then they can react. Okay, so it's kind of like dating. So if you just the reactants are just meeting randomly, so it does the chances of forming a relationship is diminished. Okay, and then the reaction activation energy is needed is very high, diba? But if we provide a dating place for them where they can sit and talk, so like a catalyst, so you can expect a lower activation energy. Okay, so that's that. That's how I make sense of this. So let's continue. Number 26. So it states that the rate of the chemical reaction is proportional to the activity of the reactants. So law of mass action niya po na siya. Next, we have a rapid increase in the rate of chemical reaction even for small temperature increase is due to. So what causes the rapid increase of rate of chemical reaction? So it letter A actually, it's letter A. So rapid increase in kinetic energy of molecules. So because rate increase in kinetic energy actually results to higher temperature, diba? If the kinetic energy increases, then the temperature increases. Is as a result, the rate of chemical reaction increases. Okay? Yan. So letter number 28. So the half-life of material undergoing second-order decay. So let's solve this. Proportional to the square of the initial concentration. Initial concentration proportional to the initial concentration, or inversely proportional to the initial concentration. So let's solve this. We have dN over dt here. So and then it's second order, right? So proportional to the square. So we have dN over dt. I know, n squared pala. N squared because this is variable separable. And then NO, then N, and we have negative k dt here. So integrate that from 0 to t. You have here 1 over n, 1 over NO, NO, and then you have KT after you integrated. Remember, so we have at so diba we are ang goal nato is to find how much time so it takes to for the original amount of the reactant to be half its value now, diba? So 1/2. So we can to find the half-life, so we must substitute that here, diba? So we have 2 over NO minus 1 over NO negative KT, then 1/2 na rin na kay half-life naman. Okay, so transpose that actually, so solving this, so we can find that the half-life is negative 1 over K NO. So meaning it is inversely proportional to the initial concentration. Naman siya sa ubos. NO. Last two numbers for this video. So the composition of the reaction component varies from position to position along a flow of a path in A or an, so CSTR. So let's draw this one. So CSTR. So CSTR, ako nyo siyang gidraw kasi nyo ganina. So CSTR. So diba, well mixed man na siya, well mixed. So position to varies from position to position. So mean this, because this is well mixed, so dili na siya maong. Adiabatic reactor does not say unsa siya nga type of reactor nga CSTR ba siya or PFR. So or unsa ba? Batch reactor. So batch reactor, batch reactor. So batch reactor. It means that there's no coming in, there's no coming out. Okay? But the component of the composition of the reaction varies from position to position. Why? Because dili man because the products nga nagawas that was produced cannot go out of the reaction vessel. So meaning it it changes, okay? Not like here that it's well mixed. So the composition is uniform throughout. So from position along a flow path. So flow path. So we have muna siya ang CSTR, muna siya ang batch reactor. Last is the PFR. Looks like a tube. Okay. And the composition varies along the length of the reactor. Okay? And it has no moving parts. The answer here is PFR, plug flow reactor. Lastly, we have a fluid through a two-stirred tank reactors in series. So each reactor has a capacity of 400,000 liters and the fluid enters at 1,000 liters per hour. The fluid undergoes first order decay with half-life of 24 hours. Find the conversion of the fluid. So let's draw that. So we have CO. Let's just name that C. So the concentration. So it goes through a series of CSTRs, diba? Stirred tank reactors man. Okay, so C1 and then C2. So here we have a the concentration of the original reactant here, diba? And then at the exit of that, it changes C1, and then after the second reactor, it changes also. So we don't know how much it changed. So let's just name that C1 and then C2. Okay, so we have V1 and then V2. This is 1, this is 2. Okay, so we have that 400,000 liters. And then we have the flow rate 1,000 liters per hour. So we are given the half-life, 24 hours na half-life. So decays with half-life of 24 hours. And then we are asked to find the percent conversion. Yeah. So in your Paris, the best way to solve this is actually it's in your Paris. Okay, so it's in table 7-3. The very first equation that you see there is this. I'll just remove the A. C. Okay, so T, the tau there is the residence time, or the space time. K is the specific rate of reaction. C is the final concentration. CO is the initial concentration. So, if we take this into a pattern na to siya diri, di ba? So, we can see that C, we have CO, and then 1 plus tau K. So, let's take that, let's pattern that here. So, we have C1, di ba? C1, CO, then over tau 1, then K1. Then C2, then C1. Diba? So 1 plus, so this is 1, 1, and 2, 2. But we know that that flow rate for both is the same. So meaning the tau here is equal to T1, tau 1 and tau 2, which is just V over F. For 400,000 divided by 1,000, you have 400 hours. Diba? 400 100 hours. 400 hours ang iyang space-time. And then we have your K. So K is actually the same for both reactant because it's just the same it's just the same chemical. Okay, so we have Ln2. This is the formula actually because this is first order. So 1/2. So Ln2 24. We have 0.0288 per hour. Diba? So because we have established that K1 and K2 is equal to K, and then tau is equal to T1 and T2. So we can just merge these two formulas. So we can have so just substitute that here, and then you will have CO, and then 1/2, and then squared, tau K squared. Okay, but we know now these values. So C2, CO 1 plus 400, and then times 0.0288, then don't forget to square that. You have 6.3466 times 10 to the negative 3 CO. And then to find the percent conversion, it's actually easy from this on part. So you have C, then C2 over CO times 100. So that's the percent conversion. So just a substitute, diba? CO here. Then we have 6.366 times 10 to the negative 3 CO over CO times 100. You can find 99.4%. Okay, that's how easy it is to find. Okay, so answer is letter D. Okay, actually that ends our this video. We just solved 30 problems all in all. So I hope you've learned from this. So if you have other questions from me, just ask me in the comments below, or you can PM me with my also providing my Facebook details here, and please also follow my Instagram, so Professor Sleep. And then actually I have to for this video I have to thank all of you for supporting this channel. So Thank you for the 436 subscribers. Last time it was 420, so we have been added 16 subscribers. So thank you, and if you haven't subscribed this this channel yet, please do so, and please tell your friends also to visit my channel and subscribe. Okay, so please like and share my videos in YouTube. Okay, so that ends our this video. So I'll hope to see you in the next one. Okay, so bye bye.